Hey everyone, welcome back. This is Vivek Bharata. In this video, we'll be covering the differences between event-driven architecture and request response with six key concepts. In request response, the communication between different services is a direct communication that is via a REST API, gRPC or RPC. But in the case of event-driven architecture, services communicate via exchange of events. So the first topic is on reactivity. Let's start with a very basic example. When a user wants to order a mobile, the first request goes to order service, right? So in the case of request response, once the order payment has been done, order service, as part of the business logic, it will send a request to fulfillment service to start the packaging and delivery process. And during the process, if fulfillment needs any other more information, it sends a request to order service to get that information and proceed accordingly. But in the case of event driven architecture, once the order has been placed, that message will be published to a topic that can be orders topic in this case. And the fulfillment service basically subscribes to this topic, and as soon as it receives a message from this orders topic, it starts processing the order by packaging and delivery accordingly. So in this EDA event driven architecture, it is fully reactive. Based on the messages it comes to orders topic, fulfillment will reactively take these messages and starts processing one by one. But as in the request response service, order service will be a synchronous API which will call to fulfillment and accordingly get the feedback whether it's able to do it or not and relay it same to the end user. Second topic, coupling. As in the case of request response, both order service and fulfillment service should be online to complete the whole process. Let's say if a fulfillment service is off for some reason, then order service also will be off because this is like tightly coupled to the fulfillment service in order to complete the order. But in the case of event driven architecture, let's say fulfillment service is off for some reason. Still, there is no effect on the order service because order service, once the payment has been done, as an example, it just publishes an event to orders topic. And as long as the order service is up, it just keep publishing to the orders topic. And once the fulfillment service is back online, it can start consuming from the same orders topic. In this case, both services are less tightly coupled. Again, the reason I'm emphasizing on less tightly coupled because somehow there is a common element that is topic over here. So let's imagine if the Kafka topic itself is off, then that's a different scenario, right? I would say that these are like a not completely independent, but a bit less tightly coupled when compared to the request response. And also, fulfillment service really doesn't need to know about the producer, like which service is actually pushing these messages. The sole responsibility for the fulfillment service would be it just simply consumes the messages from the orders topic and start processing. That's it. And the same applies for the order service also. Order service don't care whether the where exactly the messages are being consumed. It can be hooked to different service, as in this case inventory service also. But order service just keeps pushing messages to the orders topic. So in this case, all the services are a bit independent. Moving on to next topic, consistency. In the case of request response, it is easier to be consistent. Reason, order service business logic will have a synchronous call to fulfillment service to process the shipment. There could be some scenarios. In the ideal case, the orders information will be stored in the orders database itself. But let's say if suppose if there is some meta information that needs to be updated in the fulfillment service also, and fulfillment will have a separate database as an example. It will update eventually based on the different request scenarios. Now, if we think of consistency in event driven architecture, it is always eventual consistent. Reason, the whole data flow from order service to fulfillment service is completely asynchronous. Reason, fulfillment service will pick the messages based on the load. Let's say during the peak hours, if the order services keep pushing like hundreds and thousands of messages, fulfillment, let's say we have only 4 or 5 instances, so in that case it can process only one order at a time, as an example. So it will take time for the data from order service to reach to fulfillment service. So it is always an eventual consistency. I hope till this part it is clear. If you love the content, make sure you hit that like button and subscribe. Let's move on to the next topic, that is historical state. Now assume if user wants to modify his order along with mobile, he wants to add mobile case and screen protector. In the case of request response, once the order service receives the request from the user stating that the user wants to add mobile case and screen protector, the information should be immediately passed down to fulfillment so that by the time if the fulfillment hasn't been started yet, they can add it and send it in a single box. And also, for each modifications, usually the ideal way is basically we keep overwriting the same record in the database. And the same applies to fulfillment also, if at all if fulfillment maintains a separate database. So in the historical state, we always override the same record, and that's an ideal way of doing. But in the case of event-driven architecture, the order service will send out another message with the same order ID reference stating that the user wants to add mobile case and screen protector. And the same message, once it's consumed by the fulfillment service, the same logic can happen. By the time fulfillment service receives that update, if the package hasn't been shipped, then it can decide to include all the items and send it in a single shipment. So in this case, if you can think of, orders topic can maintain the whole history of the events, and it can be configurable in the Kafka as an example. But in the request response, usually the data is overwritten. Though there are some ways which can be done, but that's not an ideal way to do it. Now, fifth topic is architectural flexibility. So in the case of request response, let's say the decision has been made that the part of the business logic from other service has been pulled and needed to be turned as a different service, that is inventory service. So in that case, whenever the order has been placed or order has been cancelled, in many other cases, the order service should update inventory service. And during the storefront list also, it can request from the inventory service to get the latest data. And the same applies from the fulfillment also. Like if there is some cancellation of the orders or there are some return orders, then it should always keep updating inventory service also with a direct communication, that is REST or gRPC. So here if you see, this is also a proper synchronous operation across the order service. However, in the case of event-driven architecture, we can just simply start the new inventory service, and also it can start consuming from the same orders topic. And in the case of Kafka, we can configure how long the data should be there. So in that case, whenever the inventory service has been spinned up, so inventory service can decide from which specific message the event can start consuming. So it is fully replayable, and it's very easy to introduce new microservices and start consuming from the same topic, assuming we have higher retention of persistence data. So to sum it up, in context of architectural flexibility, it's very easy to introduce new services and start consuming in the existing topics. But in the case of request response, it will be very hard to add a new service, and we need to make sure that all the communication has been in sync, and we need to expose some extra APIs from the different services incompatible for the new service. That would be very hard to introduce new services. Now on to the last topic, data access and reusability. So in the case of request response, we can set up an ETL jobs for each database instances, and we need to maintain a proper transformers so that we can normalize and pass it down to a data lake, and from there AI, ML, all the other data intensive analytics can be done. And these ETL jobs can be attached to the secondary or reader instances, not to affect the primary databases. Again, it will be a bit clumsy if you introduce some other database, and the ETL jobs also should be attached to the new databases and all. But in the case of event-driven architecture, let's say if all the topics are there, and when we introduce a new service, the only thing we can do is, like, if there are any other topics which are binded to that specific thingy, the data lake service can actually start consuming from all the existing topics, and it can reuse all the prehistoric data and also resume from different points of time, which has a full historic data. So to sum it up, request response has a real-time business logic to perform. Uptime is very crucial, as one service failure can ripple effect to other services. Event-driven architecture shines in distributed systems or when you need to decouple services. It's especially useful for real-time applications, microservices, and systems that need to scale quickly. So which one should you choose? It really depends on the use case. If you need tight control and immediate feedback, request response is the way to go. But if you're building a scalable decoupled system, event driven is often the better choice. If you love the content, make sure to hit that like button and subscribe. Thank you so much for watching, and I'll see you in the next one.